Courses in the cement industry. Present to you. In this course, you will see the most important pneumatic conveyors, or fluidizing conveyors. Air slide. Course 2. Air slide or fluxo slides are used for pneumatic conveyance of powdered materials such as raw meal and cement. The air slide consists of a rectangular duct, with two compartments separated by means of a polyester diaphragm. Air under pressure is applied to the lower compartment normally by a fan. The aerated material flows like a liquid, at a suitable inclination of the conveyor, 4-15 degree, depending on the type of material conveyed. Course objectives. 1. Fluidizing conveyors. 2. State the purpose for air slides. 3. Name the main components of an air slide. 4. Explain the principle of operation of an air slide. 5. State the applications for air slides in cement manufacturing. 6. Describe running and static inspections for air slides. 7. Describe troubleshooting procedures for air slides. 8. State safety concerns related to air slides. 9. Perform a running and static inspection on an air slide. Objective 1. Fluidizing conveyors. The design of the air slide air-activated gravity conveyors is based on the principle of fluidization. Fluidization reduces the angle required for material flow. When air is introduced into material that can be fluidized, the material will have a tendency to flow somewhat like a liquid, so it is possible to move it almost horizontally. For example, if a material has a normal angle of repose of 47 degree, it may not flow in a spout, until an angle of 52 degree is achieved. However, if this same material is fluidized, the aerated angle of repose could be as low as 4 degree or 5 degree. Therefore, the material could be conveyed at about a 5 degree, or 6 degree slope. The degree of inclination depends on fineness of material, and roughness of the porous partition. Air slide is an inclined duct divided horizontally, into two unequal compartments by means of porous partition. Air is blown in the lower compartment and passes through the porous partition. The air aerates the powder, which flows down by the help of the inclination. Because the material literally floats on a cushion of air, abrasion against the porous diaphragm and conveyor sides is negligible. This principle enables dry, free-flowing, fluidizable, powdered material to be transported economically and efficiently. Ratio of compartment: 2/3 material, 1/3 air. Duct inclination: 60 to 120. Minimum amount of air: 1.5. Air pressure at fan: 250. Objective 2, Purpose. An air slide is a pneumatic conveying system, designed to move powdered materials from one location and elevation to another. Objective 3, Components. 1. Material inlet. 2. Air slide fan or blower. 3. Material discharge. 4. Material chamber. 5. Air delivery manifold. 6. Air slide ventilation. 7. Clean air chamber. 8. Canvas. 9. Airflow control valves. 10. Auxiliary components. 1. Material flow control gates. 2. Material grizzlies. 3. Material traps. See another air slide components. This air slide high capacity and long distance. Objective 4, Principle of Operation. An air slide consists of two main sections. The top section through which the material flows, and the bottom section through which air is introduced. Both sections are firmly bolted together, and divided by a layer of canvas. Air slides designed for exterior use are equipped with an overhung lip on the connecting flange, to prevent water from infiltrating the canvas. We follow together, Principle of Operation. A wire mesh is typically installed on the top side of the air slide canvas. 1. At impact points. 2. Other areas of high wear. See this video. We follow together, Principle of Operation. Fluidizing air is supplied by a fan, or blower at 15 to 20 inches of water, positive static pressure measured in the clean air chamber. The blower or fan is typically equipped with a filter, to ensure only clean air is provided to the air slide. We follow together, Principle of Operation. Control valves on the blower exhaust and air slide sections allows for optimization of airflow distribution. We follow together, Principle of Operation. The airflow created by the fan or blower is forced evenly through the canvas into the material chamber. The airflow fluidizes, or reduces the friction between material particles. The air slide is positioned on an angle of typically 7 to 12 degrees, causing the fluidized material to flow from the inlet of the air slide to the outlet due to the force gravity. We follow together, Principle of Operation. In order for material to be continually fluidized, airflow into and out of the air slide must be maintained. As a result, dust collectors or other means of ventilation are critical to the proper operation of an air slide. A properly designed air slide should operate under slightly negative conditions at all times. Air slide assembly. The following pictures illustrate how an air slide is assembled. Air slide assembly. The following video illustrate how an air slide is assembled. Air slide maintenance. The following pictures illustrate how an air slide is maintained. Air slide maintenance. The following video illustrate how an air slide is maintained. Objective 5, Applications. 1. Raw grinding. 2. Processing. 3. Finish grinding. 4. Bulk storage. 5. Bulk loading. Objective 6, Inspections. Found 2 moth to inspection. 1. Running inspection. 2. Static inspection. See this video.
We are going to inspect the kiln feeding air slide. We look at the close inside to see if there is any wear or cracks, especially the fixation at the joint. First, I clean the material on. Okay. Seems okay. Okay, one bolt is missing. I found the washer. Now we check the aeration box. If there is any material in, it's okay. That means there is no leaks inside. The fiber close is okay. Normally this operation should be done with the blower under operation to see if there is any holes on the polyester cloth. But unfortunately we cannot start the...
Objective 6, Inspections. See this table. Air slide structure, running inspection. Check for 1. Carefully open inspection ports along the length of the air slide, to evaluate material flow and proper ventilation. 2. Air slide should be operating under slightly negative pressure. 3. Inspect air slide for material and air leaks between sections. 4. Inspect air slide support structure for damage and integrity. 5. Record clean air chamber static pressures in each of the air slide sections. 6. Install gauges or measuring ports as required. 7. Inspect clean air chamber and material chamber inspection ports for proper seal. 8. Inspect all electrical components for cable damage or strain, as temperature thermocouples, plug detectors. 9. Inspect air supply manifold for leaks or damage. 10. Inspect air supply manifold support structure for damage and integrity. 11. Inspect the position and condition of all airflow control valves for each air slide section. 12. Inspect the fan or blower drive motor for material buildup on cooling fins and cooling fan inlet screen remove buildup. 13. Palm test the motor casing temperature. If too hot to touch, record temperature with hand pyrometer or contact thermometer. 14. Inspect drive motor electrical connections for damage or strain. 15. Inspect the condition of the final drive, V-belt condition, tensioning, sheaves, direct coupling. 16. Palm test fan bearing temperatures, or blower casing temperatures. If too hot to touch, record temperature, with hand pyrometer or contact thermometer. 17. Inspect the condition and support integrity of all safety guards. 18. Listen for abnormal noise or vibration in the fan or drive system. 19. Inspect fan casing for wear or in leakage. 20. Inspect the fan's main airflow control valve for proper operation. Ensure the control valve damper is rotating with the shaft. 21. Inspect the blower relief valve condition. 22. Visually inspect inlet air filter condition and integrity of filter support structure and seal. 2. Air slide structure, static inspection. Check for 1. Open all inspection ports along the length of the air slide, and evaluate material level remaining after normal purge sequence. 2. Inspect air slide material chamber, for coarse material and build-up. 3. Inspect the condition of the canvas, at each inspection port along the length of the air slide. Inspect for any indication of obvious wear, on the canvas surface or worn mesh. Inspect for any indication of canvas blinding, or indication of high moisture. 4. Open all clean air chamber ports, and inspect for material buildup indicating a hole in the canvas. 5. If material buildup is present, investigate the source. 6. Inspect all electrical components for material buildup, proper seal, damage, Wear and proper operation temperature thermocouples, plug detectors. Verify plug detector operation if possible. 7. Inspect all electrical components for cable damage, or strain, as temperature, thermocouples, plug detectors. 8. Operate air slide fan, and dust collector manually. 9. Close all clean air chamber inspection ports prior to operating the fan. Open all inspection ports on material chamber, and observe the distribution of air through the canvas. Pay particular attention to air slide section joints, looking for bypass indicating a hole in the canvas, or pore seal at section joints. Record the clean air chamber static pressures, for benchmarking against previous no-load conditions. Inspect air supply manifold for leaks or damage. 10. Inspect clean air chamber, and material chamber inspection ports for proper seal. 11. Inspect air slide support structure for damage and integrity. 12. Inspect air supply manifold support structure for damage and integrity. 13. Inspect the position and condition of all airflow control valves, for each air slide section. 14. Inspect the fan or blower drive motor for material buildup, on cooling fins and cooling fan inlet screen remove buildup. 15. Visually inspect inlet air filter condition, and integrity of filter support structure and seal. 16. Inspect drive motor electrical connections for damage or strain. 17. Inspect the condition of the final drive, V-belt condition, tensioning, sheaves, direct coupling. 18. Inspect the condition and support integrity of all safety guards. 19. Inspect the fan impeller for damage, wear, buildup, and alignment. 20. Verify the correct rotation of the fan impeller, for the housing design. 21. Inspect fan casing for wear or in leakage. 22. Inspect the fan's main airflow control valve, for proper operation. Ensure the control valve damper is rotating with the shaft. 23. Inspect the blower's relief valve condition. 24. Inspect the blower for any sign of oil leaks, check oil level. Objective 7, Troubleshooting. The following troubleshooting information has been prepared to help you resolve material flow problems associated with air slides. In order for an air slide to operate effectively, 3 distinct areas of the system must be in good working order. This includes the air slide structure itself, the air delivery system, and the dust collector used to ventilate the system. This troubleshooting information has been broken down into these 3 distinct sections for the evaluation of these common operational problems. 1. Air delivery system. 2. Air slide structure. 3. Ventilation system. Objective 7, Troubleshooting. Troubleshooting, loss of material flow. See this table. 1. Air delivery system. Problem 1. Is the air slide fan or blower shaft rotating? Test. Inspect the integrity of the fan drive system, motor, drive belts, coupling, motor protection. Problem 2. Is the fan inlet clear of obstruction, and is the filter in good condition? Test. Inspect fan inlet and filter for buildup or blockage. Clean or replace filter as necessary. Problem 3. Is the fan rotating in the proper direction? Test. Shut fan down and verify correct impeller rotation, for housing design. Problem 4. Is the fan's flow control valve open? Test. Inspect fan's flow control valve for proper operation and position. Ensure damper is rotating with the shaft. Problem 5. Is the blower's relief valve operating properly? Test. Check if the blower is venting excessive amounts of air through the relief valve. Problem 6. Is the air delivery manifold intact? Test. Inspect air delivery manifold for leaks and integrity. Problem 7. Is air being supplied to each air slide section? Test. Inspect position of flow control valves for each air slide section. Problem 8. Is air pressure high enough in clean air chamber to properly fluidize material? Test. Measure static pressure on clean air chamber of each air slide section and record. Static pressure should measure 15 to 20 inches of water. 2. Air slide structure. Problem 1. Is the material level full along the length of the air slide? Test. Open inspection ports to verify that the air slide is full along the entire length. This is an indication that material has backed up from discharge to feed end. Problem 2. Is downstream equipment operating properly? Test. Verify that downstream equipment is running and operating properly, as bucket elevator, FK pump. Problem 3. Is there a blockage at the discharge of the air slide? Test. If proper airflow has been verified as indicated above, a blockage at the discharge could be the source of the problem. Inspect air slide discharge for obstruction. If obstruction is found, investigate the source. Problem 4. Is there material in any of the clean air chambers, indicating a hole in an air slide section? Test. Open all ports on clean air chambers, and inspect for material buildup. With ports open, operate air slide fan to verify flow, and clean out any material buildup in the clean air chamber. Problem 5. Is there an indication of high moisture in the air slide? Test. Inspection ports can act as heat sinks in an air slide, allowing any moisture to condense on the inner surface. Material in this environment will stick to the moist inner surface and form mud. This is a good indication of excessive moisture content in the material. Investigate the source of the high moisture. High moisture material is more difficult to fluidize, and can cause blinding of air slide canvas. Problem 6. Is there a significant air leak between air slide sections? Test. Inspect air slide for leaks between sections. Problem 7. Is air slide canvas tight and flat, or is it bowed upward under normal operation? Test. An air slide canvas that is bowed upward under normal operation creates preferential flow to the center of the canvas. Areas close to the side wall of the air slide are as a result poorly fluidized. In many cases this is the result of damage to the air slide side walls, due to hammering to assist flow problems. By collapsing in the side walls the canvas becomes loose, and even fluidization of the material is lost. 3. Ventilation system. Problem 1. Is the dust collector system running? Test. Verify that the dust collector is in a running state. Problem 2. Is the dust collector's fan drive intact? Test. Inspect drive components, as motor, belts, belt tension, drive couplings. Problem 3. Is the fan rotation correct? Test. Verify the correct rotation of the fan impeller with the fan casing. Problem 4. Is the fan damper operating properly? Is the linkage smooth in operation? Test. Test damper drive remotely, then from unit control if applicable. Problem 5. Are remote balancing dampers set properly? Test. Verify the position of all manual balancing dampers, used to manage multiple dust collector lines, for dust collectors with multiple point collection. Problem 6. Is dust collector inlet blocked off? Test. Check for buildup in the dust collector hopper. Material buildup in the hopper can eventually block off the dust collector intake duct, completely restricting flow. Check the operation of the airlock, at the bottom of the hopper. Visually verify evacuation of material from the collector. Problem 7. Is the dust collector reading high differential pressure? Test. Note. Take the time to verify the Magnehelic indication as accurate. Blow back sample lines as required, to be confident of an accurate indication. Check the pulse sequence timer board, or programmable logic controller, PLC, for power. Verify pulse sequence on timer boards, that are connected in series. Light emitting diodes, LED, on the control boards indicate the firing sequence. Ensure all connected terminals are firing by the indication of the LED. Check compressed air manifold, at the tube sheet level of the dust collector, for sufficient operating pressure. Manifold pressure on most systems will range from 80 to 100 psi. Check the operation of all solenoids and diaphragm valves. Record the location of all malfunctioning units. Listen for the pulse on duration to determine if the timer setting has the diaphragm valve open for too long a duration, lowering manifold pressure, or too short a duration, resulting in a poor cleaning cycle. Check the manifold pressure immediately after a diaphragm valve fires, to determine if complete pressure regain takes place before the next pulse sequence. If pressure regain has not occurred, investigate air supply for leaks, partial isolation, or supply limitations. If pulse system appears to be working properly, shut down the fan and pulse the dust collector continuously, and note if the differential pressure falls. If the differential pressure is reduced to normal levels, during this period it is an indication that the dust collector may be re-entraining dust due to in leakage. The pulsing system needs to be modified for higher pulse frequency and higher operating pressure, or the collector is undersized for the current process demands. Inspect the dust collector for in leakage that could contribute to re-entrainment of material. Pay particular attention to the airlock and the collection hopper. If there is no change in the differential pressure after pulsing with the fan off, remove a bag for a permeability test to see if the bag is blinding. If the test indicates the bag is blinded, replace the bags and perform a root cause failure analysis. Objective 8, Safety. 1. Always lock out fan or blower prior to performing any service. 2. Surface and material temperature may be extremely hot. 3. Equipment is controlled automatically, can start or stop at any time. 4. Keep clothing, fingers, hair, etc. away from fan or blower drive component. 5. Inspect all guards for damage, support integrity regularly. 6. Know location, function of all control stations. 7. Keep all control stations free from obstructions to ensure access at all times. 8. Report all unsafe conditions or practices immediately. Thank you for watching, and I hope these courses are helpful to everyone. Subscribing to this channel Cement Industry Courses would be appreciated. Thank you.